Today we're going to learn about virtual private networks, or VPNs. A VPN allows you to safely move data between two private networks across an unsecured network such as the Internet. VPNs depend on authentication and encryption. Authentication to identify the sender and recipient of the data, and encryption to keep the data secure as it moves across the Internet. In this module, we're going to show you how to use Policy Manager to manually configure a branch office VPN, sometimes called a BOVPN, between two Watchguard XTM devices running Fireware XTM OS. A VPN tunnel is the virtual path between two private networks. We call this path a tunnel because it uses a tunneling protocol, such as IPsec or SSL, to securely send data. Watchguard branch office VPN tunnels use the IPsec tunneling protocol to securely send traffic between networks. A VPN gateway is the device at the end of a VPN tunnel that sends data packets across the public Internet to another VPN gateway at the other end. You can configure your XTM device as an IPsec VPN gateway. The VPN gateway at the other end of the tunnel can be a Watchguard XTM device or another VPN gateway that supports the IPsec standard. Each VPN gateway handles IPsec encapsulation for all the computers on its private network. The individual computers on the private networks don't need any special software and aren't even aware of any VPN tunnel between the two networks. When your XTM device is configured as a VPN gateway, it can look at traffic to and from computers on its protected networks. It knows what traffic to encrypt and send through the VPN tunnel based on the source and destination IP address of the traffic and its configured VPN settings. When two IPsec VPN gateways want to make a VPN between them, they exchange a series of messages about encryption and authentication, and they try to agree on many different parameters. This process is known as VPN negotiations. VPN negotiations happen in two distinct phases, Phase 1 and Phase 2. During Phase 1, the two IPsec gateways exchange authentication credentials. If one device doesn't accept the credentials of the other device, Phase 1 negotiations fail. If the credentials are mutually accepted, the two devices then agree on the encryption and authentication parameters to use to protect Phase 2 negotiations. This agreement is called the Phase 1 Security Association. In Policy Manager, you configure Phase 1 settings when you create the branch office gateway. In Phase 2 negotiations, the IPsec gateways agree on what type of traffic can go through the VPN tunnel and how to encrypt and authenticate that traffic. This agreement is called the Phase 2 Security Association. When Phase 2 negotiations finish successfully, the branch office VPN tunnel is established and data can flow securely between the two networks. In Policy Manager, you configure Phase 2 settings when you create the branch office VPN tunnel. Before you can configure a branch office VPN, you need to know the IP address information for both networks, and you need to agree on common security settings to use. Now let's walk through an example of how to set up a branch office VPN between two Watchguard XTM devices at two different sites. Let's call the two sites the Seattle office and the Toronto office. For this example, let's assume that we've already collected all the information we need to configure the VPN and that we've agreed on the shared key and the authentication and encryption settings to use for our tunnel. For our example, both sides agree to use the default authentication and encryption settings. To start, let's open the Seattle office XTM device configuration in Policy Manager. First, we need to add a gateway, so we select VPN, Branch Office Gateways, then click Add. On the General Settings tab, we type a descriptive gateway name. The gateway name is just used in the local configuration. It's not part of the tunnel negotiations. We also type the shared key. Next, we need to define the gateway endpoints for this VPN tunnel, so we click Add in the Gateway Endpoints list. We must define a gateway ID for each device. The gateway ID allows the devices to identify themselves and to recognize each other during tunnel authentication. Since the XTM and Toronto XTM devices both use static IP addresses on the external interfaces, we can use their external IP addresses each device as the gateway ID. In the local gateway section, we type the external IP address of the Seattle XTM device. In the remote gateway section, we type the external IP address of the Toronto XTM device. For the remote gateway settings, we must type the static IP address twice. Once as the IP address to use for the tunnel, and again as the gateway ID to identify the remote device. We click OK to save the new endpoint settings. The completed general settings configuration for this gateway looks like this. Next, we define the authentication and encryption method to use for Phase 1 negotiations. To do this, we click the Phase 1 Settings tab. The combination of authentication and encryption settings is called a Phase 1 transform. We want to use SHA-1 for authentication and triple DES for encryption. The default gateway configuration already includes a Phase 1 transform with these settings, so we don't need to change anything here. If we wanted to use different encryption settings, we could edit the Phase 1 transform and select different authentication and encryption settings. The other settings in the Phase 1 configuration tab are set to secure defaults, and we shouldn't need to change these because our VPN is connecting to another Watchguard XTM device that has the same default settings. Now that we've configured the gateway, we can add the tunnel, where we'll define the rest of the settings for our VPN. To do this, we select VPN, Branch Office Tunnels, then click Add. First, we type a tunnel name to identify this tunnel. The tunnel name is just used in the local configuration and is not used in tunnel negotiations. Then, we select the gateway to Toronto that we just configured. Finally, we need to add a tunnel route. In the tunnel route, we define the local addresses on each network that can send traffic through the tunnel. To define the tunnel route, we click Add. For the local address, we type the network address of the local network in Seattle. For the remote address, we type the network address for the network in Toronto. When we configure the VPN tunnel on the Toronto gateway device, these addresses will be reversed. After we add the tunnel route, the Addresses tab looks like this. One other important thing to point out here is that, by default, Policy Manager will automatically create policies to allow traffic to flow from Seattle to Toronto over the VPN tunnel we're creating here. We'll take a closer look at these policies a bit later in this module. If you want more granular control over the VPN traffic, you could clear this checkbox and create policies on your own. Now we can click the Phase 2 Settings tab to configure the encryption and authentication settings to use for Phase 2 negotiations. The encryption and authentication settings are configured as an IPsec proposal. By default, a Watchguard Branch Office VPN tunnel is configured to use an IPsec proposal with the most secure combination of settings. These are the settings we want to use. Because the default proposal uses the most secure settings, we're done here. We can click OK to save this tunnel configuration. After we create the new tunnel, we can see that Policy Manager automatically created 2 new policies to allow traffic to flow in and out of the VPN tunnel. These policies are BOVPN allow.out and BOVPN allow.in. We can open these policies to see what they allow. The BOVPN allow.out policy allows traffic from any IP address to the VPN tunnel called Tunnel to Toronto. The BOVPN allow.in policy allows traffic from the VPN tunnel called Tunnel to Toronto to any address on the local Seattle network. The XTM device administrator in Toronto uses the exact same settings to add a gateway and tunnel to Seattle. For the gateway at Toronto, all settings must be the same as the gateway settings at Seattle, except that the gateway endpoint's IP addresses must be reversed. The IP address for the local gateway at Seattle is the remote gateway at Toronto. We can look at the gateway endpoints in the two configurations side by side to see the difference. The tunnel settings at Toronto must also be the same as the settings at Seattle, except that the local and remote IP addresses in the tunnel route must be reversed. Again, if we look at the tunnel configuration side by side, we can see how the addresses in the tunnel route are different. Now that we have configured the VPN gateways and tunnels at both sides, let's take a look at how the two XTM devices use these gateway and tunnel settings to establish a tunnel. First, one device initiates a connection. This could be either device. Let's say in this example that Seattle is the initiator. So the XTM device at Seattle uses the remote gateway IP address to contact the VPN gateway device at Toronto. The XTM device at Toronto recognizes Seattle's IP address as a remote VPN gateway in its configuration and accepts the connection. Both devices are configured to use a pre-shared key as a credential method. The two devices exchange that pre-shared key, which must match. The devices then compare their configured Phase 1 settings to see if they find settings they can agree on. Since both use the default settings, they easily find common settings they agree to use. Since all Phase 1 settings are agreed upon, the two devices can move on to securely negotiate Phase 2. In Phase 2 negotiations, the two devices agree on what traffic can pass through the VPN based on the IP addresses configured in their tunnel routes, and the two devices agree on a common Phase 2 proposal to use. Since the two devices were able to agree on all tunnel settings, Phase 2 is finished and the secure VPN tunnel is established.